All right. Um, let's jump in and welcome everyone to a new pganalyze webinar on our upcoming pganalyze Query Advisor. So today we're going to talk about fixing and detecting slow queries with pganalyze Index Advisor, Query Advisor, haha. There you go. Just so you know, if you have questions throughout the webinar, please use the Zoom Q&A feature. With the Q&A feature, I see those questions pop up, and then we also have Laura from our team here who can help with answering questions that are logistical nature and such. We'll also share some resources throughout the webinar today. And then at the end, we'll have a Q&A where we come back to all the questions that may come up. So thank you again for making the time today. We will also share the recording of today's webinar with you tomorrow. So if you have any colleagues of yours that weren't able to join today, or you just want to go back and take more time to look at some of these things, you can do that tomorrow as well, or send us an email if you have questions. All right. So today there's a couple of things I want to talk to you about. So first of all, I want to reintroduce you to pganalyze Workbooks, which is something that we launched at the beginning of this year. And our team here has been hard at work improving Workbooks feature in pganalyze and basically making them a lot more useful for query tuning. Now, we'll discuss specific features that were improved there, and then we'll jump into pganalyze Query Advisor. So Query Advisor is a new feature that we're launching, which is going to enable you to basically tune a query by applying rewrite suggestions or other ways that you can influence query plans, where pganalyze basically detects issues and then also gives you a way to resolve them. We'll try to do a live demo. We'll see how it goes. I do have a backup recording in case the live demo doesn't work out. And then we'll kind of discuss a little bit about how Query Advisor works, which are the common issues that Query Advisor can detect. Of course, it's software, it's not perfect, right? So there are certain cases that it would not detect. But what we've found in our testing so far that's very promising in terms of being able to detect one of the most common problems that you will run into when you have Postgres at scale and Postgres, for example, picks a bad query plan because of bad statistics, or some of the Postgres planner quirks that just are part of using Postgres in production, unfortunately. So we'll kind of focus at the end around talking about how it works behind the scenes, and then we'll also there's a chance to join our early access program. So if you've been here today, at the end of the webinar you'll get a survey, and then in the survey we'll ask you if you're interested and basically reach out to you to work with you to test Query Advisor on your own databases. So that's kind of the high level of what we'll do today. We'll probably have about, let's say, 40 minutes of content roughly, and then we'll have time for Q&A at the end. All right, so let me jump in and basically reintroduce you to the pganalyze Workbooks feature. We actually never had a webinar where we just talked about the workbooks. We did announce them at the beginning of this year. So pganalyze Query Tuning Workbooks, we announced this right in January 2025. That's basically a feature that we added to pganalyze to let you test queries, optimize queries right in pganalyze. So before you might have done, an explain analyze, kind of had all this extra work, extra tooling on the command line or in other tools, and it's really hard to share results of explain analyze. And so workbooks are really a way to do this directly in pganalyze, to be able to interactively test different queries, benchmark different queries. Now, the general principle here, and you might have seen this diagram before if you've been in our webinars before, is actually very simple, but I think it's important to maybe reiterate how we think about slow query tuning. So you start with a slow query. The slow query is slow, and then you usually what we recommend, what I like to do, is to record what I like to call a baseline, which is basically you just start by recording an explain analyze of the slow query. The reason that's important to do is because if a query is just slow because you had a spike in I/O, and maybe the query is fast again, it's important to understand what the warm cache runtime of query is. And so I would always start with basically recording and explain analyze of the query plan, understanding how it performs now, when you ideally run it 2 or 3 times, and then okay, that's my baseline basically. Now let's assume in that baseline, right, like it might be faster than the slow situation because of I/O, but we're still seeing some suboptimal aspects of it. And so what we do then is we can basically say, let's come up with an idea of how we can improve the query. This is the hard part, and this is where Query Advisor comes in. And then we want to try out the change. And for trying out the changes, that's really where workbooks make a big difference, because workbooks let you try different hypotheses through pganalyze. And then we, again, obviously benchmark it. And then ultimately what we're trying to get to is that, we we have confirmed that we've made it faster, and then we need to figure out a way to make the change permanent. Sometimes that is different than the way that we tested a query. So maybe if I'm using an ORM, maybe I have to change my ORM function call instead of just rewriting the query. But oftentimes, just knowing that there is a way to make the query faster is really the key thing to know about, basically. Now, let me show you an example of what workbooks are trying to solve, basically, right? So this is a discussion we had internally around the slow query. We basically regress query performance in our own product. Happens sometimes, unfortunately, and we use Postgres internally, right? And so you may, for example, have a situation like this where you're basically pasting a large explain text output. Now, if you're doing a lot of performance work, right, you'll end up with a lot of explain text outputs. And so the idea behind how you would do this with query tuning workbooks is you go to query in pganalyze, or you make a new workbook through kind of the new workbook flow, and we click the tune query button here. Now, this does a couple of things. And if you're familiar with workbooks, this might seem like a repetition, but I just want to make sure that you know how this works before we dive into the other stuff. So the idea is a workbook has basically manages parameters for you. Like that's really a key aspect of how we design workbooks, and Query Advisor makes use of that as well, which is you may want to test a slow case of a query and a fast case of a query, because if you're optimizing, sometimes what happens is you regress kind of the faster one by making the slow one fast, and then the fast one, previously fast one, is slow, right? Like sometimes there's just different patterns in our data models, and so it's important to basically benchmark not just one set of parameters, but different set of parameters. And so to enable that, one of the things that workbooks do is they automatically name the parameters that come in. So that instead of using positional parameters like 1, 2, 3, we automatically give them names like database ID, collected at, and such on the screen. The other thing we basically do in workbooks is we, again, record what we call the baseline. I skipped over a step there where we actually record the plan. I'll show it to you in a demo later for Query Advisor. But basically, the idea is that we can, look at the query plans, look at the visualized version of the query plan, and then, of course, also look at the original text-based version. Now, in the manual way, right, like if I don't have Advisor, I look at this and I come up with an idea of what to change. I create what's called a variant. So variant is basically modifying the query text or other things to influence the query plan to, hopefully a better outcome. Then we can basically use that to test different hypotheses. And so in this case, for example, we had a baseline, and then we tested different versions. Ultimately, coming up with a version that was about 50 times faster than the original one. Sometimes you might want to change things, also remove things, right? So it's also sometimes, just because it's faster doesn't necessarily mean it's better, right? Like you have to think about, is this actually still solving the exact same query? But in this case, we were actually able to find a faster query plan. Now, one of the really useful things about query tuning workbooks, and again, we created this, based on using it ourselves, right? Like we like to build products we use ourselves. And so one of the key additions to workbooks has been this compare view, where we show you how the query plans differ, right? So basically, between, in this case, the baseline, we saw a nested loop that switched to a hash join. Those kinds of changes are really what the workbooks help you test. Now, let me just recap what's new with workbooks, and then we'll dive into Advisor. So with workbooks, one of the key things we added over the last couple of months is we added a new grid view. And this has been, getting this right actually was a lot of work because, Postgres explain output is good, but it has some subtle behaviors around loops, around parallel workers. And so our team really worked hard to make sure that we have, a high quality explain visualization that is a little bit more compact than our pre-existing node tree visualization. And so this grid view, basically, it looks very similar to our compare view when we compare plans. But here we're just looking at a single plan, and we basically, just show you very clearly if a query has a CTE, if a query uses loops, right? Like here we see, for example, a lot of time is spent in that aggregate node, like 37 seconds, right? We see that loop counter of 8.7 K kind of loops in it. And so just seeing clearly how a query plan performs, we found that is an essential thing to basically improve in pganalyze, because even with Advisor, you will want to verify the results, right? You would want to look at, kind of what actually changed. And so we think that this is a key new component in pganalyze that exists today already, right? So you get that benefit on the explain plans that we automatically collect. You also get that in a workbook as well now. The other thing we added is we added a built-in diffing mechanism. And again, it's important. We want to show transparently what happens, right? And so what we showed basically is when you create a variant, we show you a diff of the query text as well as obviously the query plans, so you can see clearly, what was changed, what was modified in that variant. And the other thing that we added, and this is really, key to also enabling the diffing to work well, is that we are now always formatting the queries that you work with in the workbook, right? So we're intentionally kind of doing this a little bit aggressively, I suppose, right? So we're basically like, if you paste the query in, we'll format it for you. Like we'll always format it. It's intentionally not an option. The query format, I think, is reasonable. I wrote some of the code, so if you have opinions about query formatting, happy to talk about that. But basically, the idea is that this supports full Postgres syntax, right? This uses our pgquery library behind the scenes to do basically a parse and deparse step with formatting step involved. And so the idea is that this, gives you one consistent view of how the SQL looks like in the workbook, so that you can be sure that when you run a diff, for example, that it doesn't just become one large line. So that's very useful. And then we also have something this is about to roll out, is better handling of lists in parameter sets, right? So workbooks have these parameter sets. One of the challenges we found just from feedback from people using workbooks is that if you have a query that uses an in list, for example, here we have, column 1 in 1, 2, 3, 4, 5. The problem is basically that we intentionally in pganalyze, if you have 5 in-list members versus 4, we treat them as the same query, right? And so the problem basically starts happening if the base text of the query differs from the samples we collected, and then you can't use the samples effectively. You can't paste in query text for the parameter sets. And so we've basically decided that it's best if we normalize this. There's a subtle micro performance difference between those two. But the way we look at workbooks is workbooks are not necessarily meant for, micro benchmarking, like, the 0.5 millisecond type improvements. It's more like the macro, I see a different query plan. And so for this kind of thing, we basically said, let's normalize the in-lists so that they always get treated as an array type. And so in your parameter sets going forward, you'll basically have kind of array values when an in-list shows up in your query text. Definitely looking for feedback on that behavior, but we found that otherwise in-lists just don't really work well today, and we wanted to improve that behavior when benchmarking. The other thing we've done, and this kind of goes a little bit beyond kind of just the query text, right? But like oftentimes when you're testing things, or even just sometimes permanently, you want to test what's the impact of turning off a planner setting, or what's the impact of increasing work mem, right? Like oftentimes people talking about, the default work mem setting of 4 megabytes is not good enough. But here, for example, we have, work mem of 200 megabytes. Is that, like, does it actually improve the query plan, for example? And so in workbooks, you can, now specify the planner settings, and the workbooks will, basically let you test that and let you record that if changing the planner settings actually impacted the performance, and then you can choose whether you want to just change them on a per role basis, per connection basis, or maybe you want to change them for the whole database. That said, of course, don't turn off whole planner settings on a whole database, right? So if you have things like enable nested loop, don't just do enable nested loop off on a whole database. That's a bad practice. You really should figure out the root cause of some of these performance issues or plan issues. The other thing we added, and this is, I think we'll see a lot more of this actually going forward. Right now, I think it's more the, if you know how to use it, it's really powerful. So if you're familiar with PG hint plan, PG hint plan basically lets you use planner hints in Postgres, right? And the way hint plan works is you basically put a magic comment in front of the query. And hint plan is an extension, so you have to enable that, but it is available on, Amazon, AWS, RDS and such, Azure, GCP, they all offer hint plan. And so hint plan is a way, like if you can't get Postgres to give you the query plan you want, sometimes, you can use a hint basically to force Postgres to choose a certain plan. This definitely has its problems, but one of the key things that we've done here in the workbooks, which I think will really help people who use hint plan a lot, is we added validation for the hints. So if you've used hint plan before, one of the key things that I found really frustrating with PG hint plan is it's really hard to get the syntax right. Like you basically have to do a lot of iteration around, how you specify the table name, how you, kind of like just getting the right, brackets and parentheses and such. And so what we did is we basically built into the workbooks a new validation feature for just for hint plan, which basically lets you validate without even having to run explain analyze, lets you validate if the hint syntax itself is valid, and even beyond that, if the referenced objects in the hint are correctly specified. Right. The way we do this is behind the scenes. What we use for Index Advisor, actually, we have a copy of the Postgres planner, and so we have that verification step now, where we use that Postgres planner that is in pganalyze internally. Basically, we use that to validate hint plan hints. So that really kind of makes a key difference there in terms of just being able to more quickly test different hints. And last but not least, we are making one important change here as well, which is we are renaming pganalyze query tuning workbooks to just become pganalyze workbooks. And this is looking ahead, like, don't get me wrong, right? Like, query tuning is the key feature that workbooks enable today. But we have plans to enable workbooks for other use cases, for example, for index testing, making a copy of your database, testing things in a way that today workbooks don't support yet. But there's basically a long tail of interesting things we're planning. And we felt that from a naming perspective, query tuning workbooks was a little bit of a mouthful. And so we shortened this to pganalyze workbooks. And so in pganalyze today, you have a query tuning menu item that will soon change to just be workbooks. Same functionality, just basically more specific to that part of pganalyze. All right, let me sip a little bit of my coffee here, and then we'll jump into demo. All right, drum roll. So this is the part where, if it doesn't work, I have a video recording that we can look at. But let me try to do this live, and we'll see if I regret my decisions. So I have this is in our staging environment where we have the feature flag for early access enabled, right? So today, if you're using pganalyze, you will not see this yet. But the idea is, if you are interested in working with us and testing this functionality, if you join the early access program, then you'll basically see something like this with your own data, with your own database. Now, let me start by saying that Query Advisor, one of the key things we wanted to do is we wanted to have it run behind the scenes, right? So Index Advisor, Vacuum Advisor, and pganalyze are really powerful because they happen automatically, even without you having to go into pganalyze to do anything, right? Like, we automatically detect patterns in the workload that are problematic. Like, Index Advisor detects missing indexes, Vacuum Advisor detects, insufficient vacuum and these kind of things. Now, Query Advisor, the idea is that it looks at all the data that we get around the explained lens automatically if you have auto explain enabled, and we basically show you that as an insight here. If you don't have auto explain enabled, you can always still create a workbook, and you'll get a Query Advisor running in a workbook. But I think that one of the really interesting things here is basically that we can do this for any query plan that comes in. We can now assess whether there is a common problem that we detect. Now, here in this database, I have 3 queries that are basically identified as having a problem. There's 2 classes of problems we're detecting here right now. We have at the bottom here, we can see this query was detected as having an inefficient nested loop with a sample that was 600 milliseconds. Not horrible, but could be better. But then the really interesting ones where we detected basically a bad query plan that used the wrong index because of an order by limit clause. And here, for example, we have more than 10 plan samples detected on that particular query, and we have very high runtime, right? Like, it's 171 seconds. So definitely something that I would want to optimize if I can. So I'll click into probably the top one here. That seems most interesting. Now here, what I see is basically just the zoom in view on one of those samples that were collected automatically, right? You'll see there's a slight discrepancy. Like, previously we saw 170 seconds, now it's 75 seconds. So we probably picked one of the middle samples. But the idea here is that this represents data that we already collect today, right? Now, what this here shows you is actually a very simple query plan, right? Like, it seems surprisingly simple, but yet Postgres takes 75 seconds to run that query. Now, we see here on the right side, we see the insights. And so we see a Query Advisor as a new insight type. And so what Query Advisor does basically is it looks at that plan and it assesses whether there is an opportunity to do something better, right? To try a better query plan. One of the things that we identify here is that this particular query, had a very high number of rows removed by filter, right? So you see we have an index scan index scans are good, right? But the problem is we're using an index in a way where the index itself actually is only used for sorting. Like we basically, rely on the B-tree sort order, but we're not filtering with the index, right? You see that here we have this filter condition, and filter conditions in Postgres mean that it's basically filtered after the index is applied, right? Like we got all the data from the index, the whole, 10 million rows basically, and then we applied the filter. And so this is just, a really inefficient way of doing this. And what we basically identify here is that there is an alternate index that could be used, right? Um, Now, the thing I can do, right, is I can click here, create workbook. Now, this basically takes me from, this issue that was detected in the background to create a workbook. One of the key things here is, I might have had this issue happen, but maybe it doesn't repeat, right? And a part of the Query Advisor workflow is that we should record a baseline first to confirm, is this actually still happening? So here now I have my query. I click choose parameters. Now, because I'm on our staging environment, I don't actually have any specific samples here. I could, if I'm on our prod environment, for example, I could just pull, parameter sets from our query samples, right? So if you have query sample data enabled, you can literally just click a button here. But here in this case, I could specify it manually. I'm actually going to go to our other system here. I checked before that this is, safe to share here. And so I can just copy and paste one sample here. I think this was, recorded as a relatively fast runtime. I'm just going to go back to, the sample list here, pick a slower case as well, just to kind of illustrate, how that behaves. So I have two samples recorded here now. This, basically gets me a good test case here, one fast one, one slow one. And now I'm just going to record my baseline, right, to confirm, is this actually still happening? Now, I could use the manual workflow, right? So with the manual workflow, you just copy and paste and explain, analyze. But that doesn't make for a good demo. So I'm going to use our collector workflow. This is pganalyze basically executing this for you through the collector on the database. Now, what happens behind the scenes, right? Like we basically pass this to the collector executes it with a special role that can only execute explain analyze, doesn't actually have permissions to return any data, just returns the explain analyze results. Now, it takes just a moment to record, and we see, the first one ran in 1.5 seconds, the second one ran in 6.4 seconds. Reasonable runtime, but definitely, not great. Faster than what we saw, here, right? So that just to contrast this, like here we saw 75 seconds of runtime, but now in the workbook it was 6 seconds. Now, why is that so much faster? It's because we, in this case here, we run the query 2 times automatically because we want to intentionally get a warm cache result, right? Like we're not trying to get a cold cache result, we're trying to get a warm cache result because that way we can optimize it, we can test variants. Versus here, you can see, a lot of that time was actually spent in I/O, right? And we're basically intentionally not testing the I/O part of this because the concept here is that if we can get this runtime down by working with less data, then we can actually optimize the cold cache case as well. Now, here I have my workbook. This is very similar to what I was showing you previously, but the key addition here, and this is, where Query Advisor comes in, is the Query Advisor now also on the workbook assesses all these plans that are recorded in the workbook, and it says, is there something wrong that I know is wrong, right? And so here, for example, we detected this wrong index, right? We also, you can see here, we basically detected that in those samples, right? So here, if we go through, we can, use our grid-based view to, look at this query plan again, just confirm, this is still doing this bad behavior here with, picking up the bad index basically and removing these rows. Now, I can go here and I can create a new variant. This here right now just, basically gave me a new blank slate, right? I can change the query text here. Another part, that's the magic that makes this work, is the fact that here, once I'm in the editor, I can actually apply changes based on the Query Advisor insights, right? So here on the right side, we see Query Advisor, we see, this detection again found here, but then I can click the apply button. And when I click apply, what happens behind the scenes is we basically rewrite the query for you to make a change that should influence the query plan to the better plan, right? So we know a pathological pattern, we know a way to resolve it, we change the query plan for you. Now, in this case here, this is one of these, tricks that Postgres experts know, but probably a lot of people don't. When you have this problem of order by limit use in Postgres, you can basically force Postgres to not use the index for that particular order by condition by adding a +0. You'll also note that it actually says $0 here. That's intentional because we're always creating a parameter for every kind of constant value that shows up in a query. Now I can still edit the query, right? So I could, for example, go here. I kind of don't like that comment here. That seems unnecessary. So I can still edit the query, but the key change is basically this, addition of the +0 in the order by clause. All right. So now I'm going to rerun the explain, and I'm going to use the collector workflow again. Wonderful. I like it when demos work. Okay, wonderful. So we see if we now click on the workbook, we basically recorded the variant with that modification, right? Like it ran another explain analyze. And so here you can see now that in the workbook, we see that for this variant one, this was applied, right? We still see the original backlink to the plan where this was found if we want to, kind of trace what happened. But then here, I can see the key improvement and I can already, spot that this is much faster than what we saw earlier. But if I want to, for example, look at all the plans again, you see here that we actually, for the parameter set one, it turned from 1.5 seconds to, basically 500 times improvement. No, 250 times improvement, something like that. And then for the second case, which was the really slow one, we went from 6,400 milliseconds to 5 milliseconds, right? This is also the case, by the way, that we mentioned in the webinar description, because it's that beautiful, like it's that simple of an improvement in a sense, right? Like just because Postgres really got this plan wrong, right? Now, the other thing to know here is, why did Postgres get the plan wrong, right? Like, why would Postgres do that? And ultimately, you can actually see this here really nicely. You can see this based on the cost, right? So the Postgres planner is a cost-based planner. It estimates, how expensive something is based on statistics. And sometimes that works really well, but in this case, it didn't, right? And so you can actually see on the improved version, the one that's so much faster, you can see that, the cost went up, right? So the cost for parameter set 2 was 15,000 cost units. And now this went up to 79,000 cost units. And so the idea basically here is that Postgres by itself would not choose the right query plan, right? Let me actually, somebody's asking about the parameter values. So let me show you how the parameter sets work. So the parameter sets, this is part of workbooks, right? And this is, kind of how we defined this, right? Like behind the scenes, we basically had two different database IDs, right? So these were the input values to that query. And so the idea is basically that we were testing with these two different customer database IDs in this case. Obviously, for your own workload, that will be different, right? But the idea basically is that we want to validate that in both of these cases, it got faster, right? But again, we could also, look at the compare, for example. So if we want to, just dig in and basically see what changed. This here shows you that, we basically changed the index usage, right? So here in the bottom right where it says index usage, we basically see that previously plan A, the baseline was using the primary key index, and then plan B was using the database ID schema table index, right? And so also, again, the difference here, rows removed by filter, was a lot here. And then here this changed to basically, not have any rows removed by filter, right? So that's the plan change that we brought about. But really what the query advisor did for us here is it basically told us, this ancient Postgres lore of how to fix this query plan. We basically, encoded that in Advisor for you so that you could just need to basically click apply, and it helps you try that out. So that's simple. This works surprisingly well. Obviously, now you'd ask, can I fix this another way? So you could, of course, right? So this is ultimately a misestimate. So Postgres, basically what happens here is Postgres thinks that it's more likely to find enough rows that are sorted where, this filter basically doesn't filter out that many rows. And so it can return early because of this limit, right? So you could theoretically try to solve this through statistics as well, like raising your default statistics target, maybe in some cases using extended statistics. This is one of the things we are planning to expand, some of the things that advisor can tell you is maybe, trying like a raising statistics target. But just in terms of testing, it's so much faster to basically rewrite the query here and validate the change this way. All right. Let me change back my screen share here. And then somebody asked about how to have early access to this. So the answer will come to you a little bit later in the our today's webinar. But basically, if you're interested in accessing this, in the post-webinar survey, just tell us you're interested, or send us an email, and then we can talk about kind of getting you access and testing it on your own database. So inefficient nested loop. Let me show you this one more time. So we here, right, like we basically saw a nested loop. We saw an outer table and inner table. There was a misestimate here on the rows, estimated rows to the actual rows. And then the problem here basically is Postgres should have used the hash join, right? Most likely. The idea, again, just to show this, the rewrite here is you basically change the query plan to specifically force Postgres to use a hash join by materializing it, right? So you basically move parts of the query into a CTE, you materialize that CTE, and then so this way we can basically make sure that Postgres, or most likely make sure that Postgres will instead use a hash join in this case. And so just to show you the compare view here again as well, here we basically see, the plan A was the original before we applied that insight. Plan B is after we applied the insight. And so we see that now what was, very deep nested loop. There's still a lot of nested loops here. I think I count, 7 nested loops, 8 nested loops, 9 nested loops in the original, which turned into 7 nested loops in the rewrite. So we're definitely still getting nested loops, which aren't necessarily bad, right? Just to make that clear, so nested loops are not always bad. It's just that sometimes Postgres unintentionally, well, intentionally, but incorrectly chooses a nested loop. And so that's really the key thing here with rewriting the query to get that hash join. So again, this happens, like Advisor just does that for you, so you can test if this improves the performance. All right. Order by limit we already talked about, right? So this is more just repeating what we did in the demo. But again, it's by comparison actually a relatively simple rewrite by adding the +0 here. And then the other things we're looking at, so one of the things that we did here is we basically built a pattern library of known bad patterns, and we started with those that we found to be most common in our experience. But there's many more, right? Like there's I recently somebody shared that Workbooks worked really great for them to test an OR to union transformation. That's one of the things that we can also do programmatically, right? And kind of suggest to you to try that out. There's obviously a lot of plenary hint suggestions that we could do based on bad query plans. And then also around, memoize, for example, that can oftentimes, lead to odd query plans. We have some cases recorded around group by ordering where we were able to help people, in a previous kind of query tuning sessions, just spend time on a query, optimizing it together. That's something that Advisor will eventually be able to do. And obviously, there's a large set of settings changes that could potentially, be relevant for this, right? So think about, for example, random page cost, workmem. Both of these have, relatively bad defaults. But then, one of the things people say is like you should change random page cost to 1 or 111 or something, right? Like there's all this again lore on the internet about how you should be tuning your Postgres, and I think ultimately the way we think about this in the context of Query Advisor is we want to basically detect when it is a problem, right? When it seems like Postgres probably chose the wrong index or chose a sequential scan when it could have used an index scan. Suggest to you to try out that settings change, make it easy for you to test it, but then always validate the results, right? Like really don't just basically go and make changes based on, blog post, really test it on your own workload through the workbooks. So that's the key concept here. Now, let me tell you a little bit more about, behind the scenes of how this works. So at a high level, this is built for scale, right? So when I say for scale, one of the key considerations we had here, right? Like obviously, AI-based tooling is all the rage these days. LLMs are, kind of, I would say mainstay that's here to stay. And so one of the things to consider here was, should we use LLMs for this, right? Like you could paste the query to ChatGPT, and ChatGPT sometimes might give you reasonable results. Really the thing that, made us, well, first of all, testing things, we just found that, it's actually not that good sometimes, right? Like to get really Postgres specific advice, it's hard to really make that work well. But then also it's really expensive to run LLMs in the background, right? Like in terms of, how much you're paying for token and, it's not something that would make economic sense. And so instead we opted to basically build custom code, right? Like have a pattern library where we know that these are cases that, were commonly basically found. And we are ever expanding that library, right? Like the idea is that this is basically evolving as we see different use cases. But what we can do now, and we already have this basically in production today, is behind the scenes we're already processing 7 million plant samples per day, right? Every single day, and we could probably process 100 times more than that, right? So like it's not really limited by processing capacity today, and it is something that we can do relatively cheaply because we again have a kind of purpose-built code that does this. Now, the idea here is, right, how this works is when pganalyze, so in the auto-explain case, when pganalyze gets an auto-explain sample for automated explain integration, that is, basically near real-time collection, right? Like it's log-based, depending, on the provider. Sometimes, it takes up to 30 seconds, but we basically pick those up as they happen. Then as the sample comes into pganalyze, we basically run a first initial phase one pattern detection where we just see, is this query potentially problematic, right? So for example, in the order by limit case, we saw there were, these kind of rows removed by filter. They were quite significant. So we basically have like a first pass that filters that out. Then, will be termed here pganalyze workload repository. That's basically just the internal pganalyze storage, right? But in that internal pganalyze storage, we're basically marking the query plans that are potentially problematic, right? So it means that there's something off about them that requires more investigation. And then we have a background process that runs on a schedule that basically verifies in the phase two whether this is actually a problem. And so we also, as part of this process, we test if there is an alternate plan likely available, right? The way we do this, for example, is in the case of the order by limit. We saw, there was a filter. Now, what we want to have is an index condition, right? Like we want to actually see an index being used to reduce the data we're looking at. And so the idea is that we basically we look at the pganalyze schema data, right? Because pganalyze has all this information about the database. And so we verify for the tables where we saw something problematic, whether there is likely, an alternate index that could be used. Then we create the query advisor insight, right? So the insight didn't yet validate the rewrite itself. It's just validated that there's likely an alternate query plan available. Apologies. Alternatively, what you can also do, because you may not have auto-explain enabled, although majority of our customers has auto-explain enabled. But if you don't have auto-explain enabled, you can also do a manual upload, right? So if you want to basically test a query, you don't use auto-explain, or maybe you're in development, right? Like maybe you're rolling out a new feature and you want to confirm whether the query plan is actually good, right? Like whether pganalyze knows anything about this, detects anything that's an issue. And so you can start a workbook, upload basically, put in your query, put in your parameters, upload the explain, and then we run that same pattern detection verification in the workbook, and we tell you if there's an insight. That also works, right? Like that's basically also a way to get that same insight. Now, the other thing we invented here, and I kind of like to term this code mods for queries. If you remember code mods, it was a thing that was people were really excited about like 10 years ago, and then it kind of stopped being a thing. And now we're all, kind of talking about, Cloud Code modifying our code base for us based on, inputs we're giving, and it's all the LLM doing it. But I think the core idea here is still, how do we transform text, right? Like how do we transform structural text like a query, a SQL query? And so the thing that we ended up doing here is, again, intentionally not choosing an LLM-based approach. This would be a potential LLM use case. But one of the challenges that I find is that I want to be sure that my transformation is correct and like deterministic, right? Like I want to be able to do this correctly all the time, not just sometimes. And so we may expand this in the future to potentially, optionally offer some LLM-based integrations, because I do think they have some benefits in certain use cases. But for the cases that we found today, where it's really about, we detect a bad pattern, we know there's a better index available, we're basically doing something simple in a sense. It's just a lot of different moving parts. So we detect the insight. We then enter what we call a query rewriter. The rewriter parses the SQL. Now we parse SQL using pgquery. That's one of our open source libraries that you can use yourself if you want to. And we modify the parse tree. This is basically a rewrite rule that says in the case of the order by limit, inside it was basically find the order by clause at that +0. In the case of the materialized CTE, it's a little bit more complicated. But basically, it's, making a structural change to the AST based on the, intent of what we want to try out. And then we deparse and format that SQL again using pgquery, right? And this is where the formatting comes in, because part of the reason why we added formatting to workbooks and to pgquery is because we go through this rewriting step here, we want to make sure that we actually were able to output a readable query again at the end. Because then you click the apply button and it just changes the query text. But really what happened behind the scenes is a parse, modify, deparse step. Now, let me close with, kind of early access and looking ahead. So before I jump into this, so if you're interested in early access, what I'll say is for best results right now, I would recommend that you have auto-explain enabled and you also have log analyze enabled. You don't need log timing. That's the expensive portion, and we don't recommend people turn it on. But log analyze is important because it lets you identify misestimates. And so that background processing that happens, on all the samples, that really only works well if you have auto-explain data that has log analyze data, so that we see when the plans went wrong and how they went wrong, so that we can then produce an insight for you, that you know which query to look at. Otherwise, you can still click through all your queries. It might just be a little bit more tedious to find a query that actually has something worth optimizing. The other thing I'll add is that if you're using workbooks today, you may not yet have the collective workflow enabled. And so in my experience, the collective workflow just makes verification of these things really easy, right? Because you can actually just go in, click a button, and test something out versus having to copy and paste a lot of things. So those are the two things I would say as prerequisites. And then we're starting our early access program on August 11th. So if you're interested in this, please fill out the post-webinar survey or send us an email. We'll send you some few more questions just to qualify that it's a good fit, at the start of the early access. But we'd love to work with you, kind of see it on your own database. Based on what we've done so far, just in terms of our telemetry, we know that there's a high chance that if you are a current pganalyze customer, there's basically a 1 in 2 chance that you'll have something useful, maybe 2 in 3 even. And we probably expect that to go closer to 80 or 90% as we add more insights. So there's a high chance that you'll have a query basically that has a problem that we can help you with. And then just looking ahead, what are we doing currently? So this is, as mentioned, early access. Looking towards GA, we're basically working on expanding the coverage of more problems we detect. There's some things that might be interesting. This is probably going to be after the initial release, but we could, potentially test these rewrites. Let me drink a glass of water really quick. We could potentially test these rewrites in the background, right? So today, you click the buttons, we do the testing. I think that's good for, controlling when you want to have, the time taken to try something out. But there's nothing in this process that couldn't happen automatically. And so one of the things I'd be interested in to hear is, if you're interested in basically having this happen at nighttime on the weekend, eventually pganalyze will be able to do that for you, right? So because we can just do this, when we have enough data, we can just do this automatically. And again, because it's a deterministic process, we can be very sure that, we don't break anything and have constraints around what we do. This would always be opt-in, right? But it's something I think that is the premise of how the system is built. Now, we're also, kind of open to saying, what are the ways that people work today, right? And so I'm personally not a fan of vibe coding, or how you'd like to call it. But I know many people are, right? And so I want to be open to, enabling those workflows for, engineers that find that useful. And so I think, on the LLM-based side, you could think about Workbooks and Query Advisor as a tool that an LLM can use. I also think that there's a use case here around pre-production testing, right? So anything, from CI to in your editor, I think there's basically a use case for Workbooks being a way to validate queries and to just make sure you get the best possible query plan. So all these are things that we're looking, we're considering. This is a little bit more, vague, I would say, on that last item. But if you're interested in this, please let us know. I'd love to talk to you about that. And that's really it. Thank you so much, for joining us today. We'll talk about the questions in a moment. And my apologies for that wrong screen share in the middle of the today's webinar. But hopefully, that all made sense end to end. And again, I'd love to see people join the early access program. All right. So if you have questions, please use the Q&A feature, and I'll kind of start kind of with a question here. Um, let's see. So there was a question that Tayfun had around tweaking the work mem of Postgres for more expensive queries. So can we use pganalyze to see what we gain or lost when increasing the work mem? So you definitely could, right? So this is one of the improvements that we've done in the kind of planner setting configuration, is you can test, for example, an increasing work mem for a workbook. You may want to, like how I would go about this probably is I would um, find the queries. Again, this is where the advisor will eventually, also have an insight for this. But right now, what I would do is I basically go and find the queries that have high sorts, like on disk, like where temporary files get created. Then create a workbook to, kind of test the workmem increase. And then if that succeeds, right, like then you could either increase workmem just for that query, right? Like workmem is a pair connection setting if you wanted, or you can increase it for the whole server, especially if the default of 4 MB is what you're currently using, then I would consider increasing that. Let's see. Tarun had a question on, does it take care of issues with a left join with large subqueries? Good question. I mean, I think this is one of the things where it probably depends on the specifics. The idea is that eventually it will, right? So the idea behind the system is that if there is a way to resolve that to improve the query, we want to basically cover, the 80/20 here, right? Like there's always going to be a long tail of things where you want to involve somebody to really work with you as a person to tune your queries. But if it's a common Postgres problem where, Postgres expert looks at it and says like, oh, that problem again, right? Then, it should, the intent is that advisor takes care of that. But if you're interested, I think what I would say is reach out to us for early access and we can take a look at this. And we can, add the advisor and the human portion, and then we'll improve advisor as we go, basically on seeing those cases where it doesn't detect things maybe yet. Um, all right, and then there's a question that Jesse had around for query rewrites recommended by Query Advisor, how are we able to ensure that the recommended query rewrite returns the same result sets for all sets of possible input parameters? That's a great question, right? So the question basically is like, if I change my query text, isn't there a risk that, I change the query's intent basically and Postgres actually does something very different? This is the thing where for these two insights that we discussed today, um, I trust from a correctness perspective. I trust them basically 100% because they're very straightforward in terms of what they do and what we know Postgres is getting wrong, and it's really a misestimation problem, not a you should have changed the query to let Postgres do something better problem. Let me put this differently. Sometimes there's cases where Postgres couldn't possibly find a better query plan. The cases we looked at today are basically Postgres gets it wrong. We know why it gets it wrong, and it kind of should really fix it, but there's reasons why people don't. But basically, we know that the modifications are correct. Now, that may not always be the case, right? So that there might be query advisor changes where the result set does change because you might add an additional where condition. Like we might basically recommend you modify the query like just to improve performance. And assuming we do that, right, like then first of all, we would put a big warning sign on it, right? So if the result actually might change, we'll tell you. But then we can actually validate at least the result count today from data we have. We can't, like, the way it's designed today is we don't see the actual result data, right? So when it comes to basically saying, does it still return the exact same results? You would have to do manual test. It would make it a lot easier, copy and pasting queries out of pganalyze. But that's where I think a human component basically is a bit hard to replace, at least in the interim. But our intent always is that these rewrites basically don't change the output. They just change the query plan. And then Bobby had a question on, does the query advisor take the Postgres version into account? Does it suggest or not suggest certain things based on the Postgres version? Good question. It certainly would. The things we do today are unfortunately known not to be fixed in your Postgres versions. Like basically, even though we've been talking about order by limit problems for many years now in the Postgres world, it's still a thing even in Postgres 18. And so if that was the thing where something was fixed in a newer release, we we have all this information, right? Like one of the examples, we talked about PG hint plan a little bit in the beginning. The hint plan validation is actually version specific. So we actually run the Postgres planner for the correct version. And so we have all the tools internally to basically build Postgres specific validations, like Postgres version specific validations. It's just that right now, it's not yet something that's relevant for these insights because they apply universally across all Postgres versions. But yeah, certainly we would take that into account. And then I think Les had a question, which was a follow-on to I think Jesse's question, which is, would it make sense to compare a hash of the result set, right? So to validate whether the result changed, could we just look at the result set and validate the hash? That comes down to, from a permissions perspective, at least for the collector workflow and workbooks today, that one doesn't actually have enough permissions to look at the results, right? So it can't actually, it couldn't run a hash in the result set. But with additional permissions and the right functions, basically, that would definitely be something that we could enable. So yeah, I think we'll take that into consideration, I think, as we expand kind of the more riskier insights, basically. And then I think William had a question on this being the same as query tuning, and I think this is really maybe just to repeat kind of what we're doing here, right? It's like we're basically splitting query tuning as a feature set into two components, right? Like we're basically turning the query tuning workbooks into a standalone workbooks functionality in pganalyze, and then Query Advisor does work with these workbooks, right, as we looked at today. But it's basically like they're both part of query tuning. We're just kind of renaming this for clarity and saying, query tuning workbooks are just workbooks. Query Advisor is a new top level menu item in pganalyze going forward. All right, wonderful. Well, I think these were all the questions. If anybody has more questions, please, feel free to reach out. Actually, there was one more question the chief had right now, so let me get to that, and then we'll close. So chief had a question on how would Query Advisor work with LLM tools in pre-production testing. So I think that went to the last item I had on the last slide. So basically, imagine like all of what we looked at today, there were a bunch of clicks involved. There's no reason that can't be driven through an API, right? So all of this could be driven by a local dev tool or a local LLM to do the same like steps, basically to say optimize this query like the same way a human can paste a query. An LLM based tool can do the same thing, right? And so this is just one of the use cases we envision here, is that this can be a validation step when you have kind of SQL statements authored not by a human, but like by a human working with an LLM together. That this can be a way to validate performance of this. So again, if you're using that today, I'd love to talk more to you about it to see how you could see this fit into your workflows. But it is built to be possible to use this for the API as well. Wonderful. All right. So I think we got to all the questions. If you want to try it out, fill out the post-webinar survey. If there are more questions, we'll get to them by email, include them in an email we send out tomorrow. And thank you again for joining us today.